So HiCounselor is an online accelerator that helps job seekers find full-time jobs or internships as well. HiCounselor helps candidates with interview prep as well as getting the interview calls. We utilize artificial intelligence-powered job search algorithm and strong network of 300 plus employers to help candidates land a job. Every candidate gets personal attention and mentorship from professionals like myself who come from top tech companies. The payment structure at HiCounselor is income share agreement, where you don't pay anything to HiCounselor until you land a job. So once you land a job, you pay a fraction of your first year salary in monthly installments. So there is nothing upfront. If you're currently looking for a job, HiCounselor could be a great resource for you. The cohort at HiCounselor starts very soon. So if you're interested, please apply on hicounselor.com. Feel free to use my code Andrew, and you will get $500 discount when you start paying HiCounselor after landing a job. So my name is Andrew, and I'm a software engineer and tech lead for companies like Microsoft, LinkedIn, Snap, IBM, BlackBerry, and I'm going to be your instructor for the course, Software Engineering Prep. If you're targeting PM role at top tech companies, I would highly recommend you attend the course because this course is absolutely for free. We will cover everything from software engineering to a technical interview to mentorships to go-to-market strategy during this course. I will be covering important topics, most asked interview questions, and the most efficient ways to solve them. I have more than 7 years of experience in software engineering role at top tech companies in the US, and I have helped a lot of candidates with interview preparation. I'm very excited to help you land your dream role. So sign up for the course, and I look very forward to meeting you in the upcoming sessions. In this session, we're going to be covering dynamic programming. Okay, so what is dynamic programming? So essentially, it's also called DP, and it's mostly leveraged to optimize and make more efficient the recursive algorithms because they tend to scale very exponentially. That's the most important part. They scale exponentially. So the ideation is to sort of compose down complex problems that has numerous recursive calls, and then into smaller sub-problems, and then save them into memory such that we don't have to recalculate them every time we use them. So what is dynamic programming? It's a programming principle where a very complex problem can be solved by dividing into smaller subproblems. The principle is very similar to recursion, but with a key difference. Every distinct subproblem has to be solved only once. And to understand what that means, you first have to comprehend the problem of solving recurrence relations. So every single complex problem can be divided into very similar subproblems. So this means that we can construct a recurrence relation between them. So let's give you an example. Fibonacci sequence, right? Fibonacci sequence is defined with the following recurrence relation. So the recursive relation is an equation in math that recursively defines a sequence where the next term is a function of the previous terms. And so the Fibonacci sequence is a great instance of this. So if we want to find the nth number in the Fibonacci sequence, we know the two numbers, we have to know the two numbers preceding the nth in the sequence. But every single time we desire to calculate a different element of the Fibonacci sequence, we have certain duplicate calls in the recursive calls, as we can see in the Fibonacci number. So for example, if we have this, if we have something like this, right? If we want to calculate F5, which is Fibonacci 5, we obviously need to calculate F4 and F3 as a prerequisite. But to calculate F4, we need to calculate F3 and F2, which in turn makes us calculate F2 and F1 in order to get F3 and so on. So that repeats calculations, which is essentially redundant, and that slows down the algorithm significantly. So we use DP. So in that approach, we model a solution as if we were to solve it recursively. However, we solve it from the ground up, essentially memoizing the solutions to the steps we take to reach the top. Therefore, for Fibonacci sequence, we first solve the memoized F1 and F2, then F3 using the two memoized steps. This means that the calculations of each individual component of the sequence is O of 1, because we already know the former two, right? So when we use DP, we have to know 3 steps. Number 1, determine the recurrence relation, which applies to the problem. Number 2, initialize the memory or the matrix's starting values. Number 3, ensure that when we make a recursive call or the access the memoized solutions problem, it's always solved in advance. All right. So let's do an example. So Anuj, imagine you're given 2 strings, S and T, and you have to return true if S is a subsequence of T or false otherwise. S and T, and you have to return true if S is a subsequence. So what is a subsequence? Obviously, it's a new string which is formed from the original string by deleting some of the characters or none of them without disturbing the relative positions of the remaining characters. For example, ACE is a subsequence of A, B, C, D, right? While AEC is not a subsequence. Okay, so I want you to maybe think about this for for a couple of minutes. You don't have to write the code down, but maybe think of how you would approach this using maybe dynamic programming. All right, we'll come back and we'll solve it together after. Okay, so let's take a look at the solution and how we should approach this question. So when you have dynamic programming problem, well, there's a couple solutions. One is obviously with DP. One is simply using 2 pointers. And we're gonna approach several ways to solve this. The first solution is quite easy. So here, we first checked if the S length is 0, which means it's always going to be true because that's going to be S is a subsequence of T. Now we calculate the index of each starting at 0. So while the T index is less than the length of T, we rerun some operations. And then that's when we're going to check if that's true. So if the T dot character at T's index is equal to S dot character at S index, we're going to have to increment S's index. So now we're at the second index, right, for S. So after that, if the S length is equal to S index, we return true. So every time we check the T index being equal to S index, and we know that S length is equal to S index, meaning we are at the end of the S, we have to return true. And then once we're out of this if statement, then we increment the T index because we want to check for the next index of T, which is a string. Right? And then once we're out of this, and then we still haven't found it true where S length was equal to S index, then we return false. So this is one of the solutions. So how do we go about a dynamic programming, right? Because after all, we're trying to do that in this tutorial. So with dynamic programming, first solution we think of is let dp at I and j equal to 1 if s is a substring of ti. So here we're going to use Python. So how do we find it? So here we also use, here we're using s is equal to s, which allows us to handle border cases with empty strings. That's why we're using s statement here. So how does the code look like? And what's going to be the complexity? The time and space complexity of this is going to be O of nm, because we need to iterate over all table once, right? So it's going to be n times n. So let's write down the solution. So in this solution, we first let the dp of I and j equal to 1, right? And if s is a substring of t, then we say that dp of I and j is equal to 1. Okay, here, what we did is we first let s and t equal to this line to ensure that we handle border cases with empty strings. We say that m and s are the length of s and t. We say that dp is equal to the dynamic programming matrix for the range of n. And for the I in range of n, we say that the dp is set to 1 for all the i's with the j equal to 0. And then for I and j, in the product of this, we do two cases. If S is equal to T at J and I, then we say that DP of current index is equal to the previous one. And if that's not the case, then we say that the DP is equal to only a previous I matrix. And then in the end, we return the -1 and -1. We already did how to solve this using 2 pointers. And then we can also use this. We can also use binary search for another solution implementation. But enough for this question. And then I want to give another very good example question. So the question is, if you have a Pascal's triangle like this, you're given a row index, and you have to return a row indexes row of Pascal's triangle. So remember, each number in that is the sum of the two numbers directly above it, as it's shown. So let me give you an example. If we're given row index of 3, the answer should be 1, 3, 3, 1, because it's 1, 3, 3, 1. If we have row index of 1, that should return 1 and 1. So given the integer row index, you have to find the row at the row index's index. So this is the input, this is the output. I'll give you, a couple minutes to think about it, and then we'll solve it together. All right, so let's take a look at how the solution might look like. So we know that in this case, we're actually solving many things over and over again, right? Because we're just pushing it, solving one subproblem to another subproblem until we find the answer. So in this case, in this solution, maybe you could try a different language. Here, we're going to use C++. Yeah, we're going to use C++. And we're going to return a vector of integers. And we're going to get the row with the row index. But the idea is pretty similar, regardless of the language. So what's the runtime going to be? It's going to be very fast, faster than a lot of solutions, because we're just iterating the row index from 0 all the way to the end. And then also we're iterating from the J from the mid-range to the 0. The memory usage is not going to be big. So what's the solution here? Here we say that if we initialize result variable, so we declare the result vector of integers. We declare a mid-range integer, and then from int 0 all the way to row index, we increment. So what we do, we push the back 1, right? So we push the back number 1 to the result, and the mid-range is updated to be the result size -2, right? So after that, for the integer j, starting at the mid-range, all the way down to 0, we say that the result at j is going to be the addition of the two previous results, which is result j -1 plus result at j. All right, so this part is the DP part. The mid-range is just for the reference for the argument in the fourth loop here. And then we push back 1 into the result because we're doing Pascal. All right. So here's another interesting question. So you're given an array cost, okay? And the cost at I is the cost of ith step on the staircase. Once you pay the cost, you can either climb 1 or 2 steps, all right? And you can start from this. You can start from the step with index 0 or the step with index 1. So your goal is to find the minimum cost to reach the floor's top. Okay. So let me give an example. If you have the cost 10, 15, 20, your answer is going to be 15. Why? Because the cheapest one is start at cost 0, pay at that cost, and go to the top. Because you can either climb 1 or 2 steps, right? So that's going to be the answer. So I'll give you a few minutes to think about it, and then we'll solve it together. Cool. So we know that we can either do 1 or 2 steps, right? And we need to find a minimum cost to reach the ceiling or the top of the floor. So how do we go with the art of dynamic programming? Well, we know that all possibilities are considered through brute force or top-down depth first search, right? But we have to remember that each sub-problem's optimal solutions, each via DP memo. So we turn the top-down solution upside down to create a bottom-up solution. And then bottom-up memory optimization. For that, we instead of storing the entire DP array, we only need the last 2 values. So how does it look like in terms of solution? Well, first solution is minimum cost. Oops. Yeah. So minimum cost self a list. Integer. N is going to be length of A. And definition at go is such that if n is less than I, return 0, right? But we return A at I plus the minimum of go at I plus 1 or go at I plus 2. Return min go at 0, go of 1. So this is going to be the base case. We reach the top floor. And here, the case is such that we have a recursive case. And the cost of ith step plus the minimum of 1 step or 2 steps, right? And here, where we return the minimal cost beginning at first or second step. So that's the solution, like this. So I do want to thank you for your attention and participation today. And again, if you need assistance with job search, mentorship training, group coaching, or how to talk to recruiter and maximize your chances into getting into big companies in US, HiCounselor could be a great resource for you. Again, the payment structure at HiCounselor is nothing, where you don't pay anything until you land a job. It's called income share agreement. So when you land a job, you only pay a fraction of your first year salary in monthly installments. So there's going to be nothing upfront. The next cohort starts soon. So if you're interested, please apply on HiCounselor. And feel free to use my code Andrew, ANDREW, and you will get a $500 discount when you start paying HiCounselor after landing the job. I'll see you at the next session.